Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of June 5th, 2023, this time around. So it's a moon week. The moon starts the week about full and has waned to nearly about, maybe just past half full by the end of the week. So that dictates a little bit of what we can do. Early in the week in particular, it's hard to look at faint objects. What the moon will do, so in the morning sky we have Jupiter and Saturn as the bright objects glowing in the east before sunrise, and on the morning of the 9th and to the morning of the 10th, the moon will slide below Saturn. By the time we get out here, it's approaching its half full, right? And so this is something to keep in mind, and something to keep an eye on is the moon sliding by Saturn in the morning sky. In the evening sky, I hope it was clear and you had a chance to see Mars interact with M44, the beehive cluster in Cancer. And so we're going to turn our attention back to that direction in the evening sky. Mars has continued to track well off to the east, and Venus is approaching the beehive cluster and will skirt right by it next week. So we'll talk about this again a week from now, but you can see it closing right in on the beehive cluster. So let's explore this region just a little bit. So Venus we talked about this a few weeks ago. Venus is still closing the gap on Mars. So this is fun to watch as Venus is closing this down. But that gap, you think Venus is going to catch it, but it's not. Venus is going to start to go into retrograde motion, and we're going to slide back the other direction. So what we want to do is take this opportunity to identify the stars of Cancer. You got Delta here, just below the beehive cluster. So you've got Mars, Delta, and Venus like that. So we want to see if we can figure out Delta. And then we've got the Alpha star down this direction. So find these stars, Mars, Venus to Delta to Alpha like this is a great thing for us to try to find. If we go the other direction, we've got Zeta, and then we've got Iota up this way. So we see this sort of, I probably stretched that to Iota just a little bit, but we see this sort of whatever that shape is up here. Zeta and Iota are both good double stars for you to observe if you have a small telescope. Iota is a pair of stars pretty widely separated, but they seem to be, they're associated in space because they're flying through space together. So they look like they're a true binary, or a true pair anyway, going through space, separated by about 30 arc seconds. An arc minute, recall, is a 60th of a degree. An arc second is a 60th of an arc minute. And so we've got half an arc minute up there. That's a really wide separation. You have a small telescope with a wide field of view, a low power eyepiece. You can see this separation pretty well. It's worth trying to check out. Zeta is an interesting triple system. It's got 1 arc second, 2 stars that are 1 arc separated by 1 arc second, and I don't remember what the orbital period, 60 years, 70 years is the orbital period of those 2 stars. Pretty tight, pretty hard to see, but there's a 3rd star in the system that's separated out here, and it's about 6 arc seconds away, and it's moving very slowly, and it's got a period more like 1,100 or 1,200 years as it orbits around that tighter pair in here. But to see if you can resolve those stars that are 1 arc second apart in Zeta Cancri, and see if you can, it should be able to see the 5.8 arc second separated star relatively easily. So you got a small telescope, that's something for you to check out. Also check out M44, the beehive cluster right here in the heart of Cancer, and check out, this is all wacky here. But check out M67 down here just south of Alpha, another open star cluster. Big, wide open star cluster, great in binoculars. Starts to fall apart in a small telescope. It's so big. And you need a really wide, really low power eyepiece. M67 is relatively faint. It's got older stars in it, lower mass stars on the main sequence still. And so they're hard to see here a little bit. You probably want a telescope to do this, to check this one out. But come down here to Alpha and check out M67. Now, one of the things we know about these, we talked about this a little bit recently, I think. If you make a graph for a star cluster like this with temperature of each star in the cluster, the temperature increasing this direction and the luminosity increasing up this way, we would call that an HR diagram. on the main sequence. Main sequence stars are stars that are fusing hydrogen into helium in their cores. So way down here in the middle of the star, that star is fusing hydrogen into helium going on. High mass stars, these are brighter, higher temperature stars. Brighter's up this way, higher temperatures this way. These brighter, higher temperature stars leave the main sequence first. They run out of fuel in the core. And when they do, they ascend the giant branch. So what happens is they become red giants and they start fusing hydrogen into helium in a shell around this inert helium core. And so the high mass stars disappear from the main sequence and they go over here to be red giants. So you see this sort of shape, the stars look like this, and we call this the red giant branch. These stars that are fusing hydrogen into helium in shells around the core up this way. And so you can tell the age of a cluster by how far you've eaten away down the main sequence. We call that the turnoff point. And where is that turnoff point? This is a nice middle-aged cluster. M44 is a nice middle-aged cluster with the turnoff point here. Young clusters would have a turnoff point way up here. Old clusters have the turnoff point way down here, so that they would come up here and the stars will have left the main sequence and gone up to the giant branch way down here. And that's what M67. M44 is going to be right here, a middle-aged cluster. M67 is a very old cluster down here. There are a few clusters that are older than M67, but it is among the oldest clusters down here. So this is, we see this low turnoff point, something to think about the evolution of stars and how we measure the ages of clusters as you look at M44 and M67 this week, and you check out the double stars, the binary stars, triple stars that are in this Cancer area. Now, a couple other things just for the fun of it. As you're watching, turns out that this is all just for the fun of it, so there you go. As you're watching Venus close in on the Beehive cluster. Mars scooted right through the Beehive cluster last week. Venus is closing on it this week. It'll get there next week. We'll talk about it. And it's closing the gap on Mars. They're each going to pass fainter stars, stars that are about 6.3 magnitude. And remember, in a really dark skies, your naked eye limit, the limit you can see without aid, is going to be down somewhere close to 6 magnitude. So to see a star that's 6.2, 6.3, 6.4 magnitude, binoculars, you should be able to do it if you got good skies. Your small telescope that you had out to look at this other stuff will do it for you too. But on the evening of the 8th, this is hard to see, I realize. On the evening of the 8th to the 9th to the 10th, that's Mars that I've got right here, is the 8th, the 9th, the 10th. And there's a pair of stars that are sort of 6th to 7th magnitude stars right here. And it would be great fun to watch Mars close. 8th, 9th, 10th. It's right there making a really close pairing, tripling with these other two stars, these fainter stars. See if you can see these stars. Start a couple of days in advance before you get to the 10th to watch Mars track across and join these other two faint stars and the outskirts of Cancer. Not quite the outskirts, but getting out into the edges of Cancer. Now Venus is going to do something similar from the morning of the 9th to the 10th. Here's a fainter star, and Venus is going to scoot right by it, and it's also about a 6.5 magnitude star. So Venus is going to go from here to here. And so while you're watching in the evening of the 8th, the 9th to the 10th, you can watch Venus do the exact same thing over here and start to really get a sense, start to really get an appreciation for the motion of these planets against the background stars. So that's what we got for you this week. Think about the ages of star clusters. A star cluster is a group of stars that was born at the same time out of the same cloud of gas. They have all the same initial chemical composition because it was the same cloud of gas, and they have all the stars in the cluster of the same age because they were formed, gravity formed them at the same time. And so any differences in evolution like this have to do with differences that are intrinsic to the star. And higher mass stars are up here, brighter, hotter, and they evolve away. They use their fuel first. They're burning their fuel. They have more fuel to burn, but they're burning their fuel really, really rapidly. So you can think about that as you think about these two clusters that are quite different ages, M44 and M67 in here. Watch Venus and Mars moving against some faint stars in the background. And you can check out the moon moving past Saturn on the morning of the 9th and to the morning of the 10th, like that. On over to Jupiter. Jupiter's coming up that direction. And the moon will have a nice close pairing with Jupiter next week. So that's what we got for you this week. Hope you have a good week, everybody. Hope you have some clear skies. And as always, thanks for watching.